Imagine building something amazing, like a car engine or a strong pipe for carrying water. You would need a material that is incredibly strong, but also has a little bit of give, something that can bend without breaking. This is where a special kind of iron, called ductile cast iron, comes into play. It's not your everyday brittle iron that shatters if you drop it. No, this iron is engineered to be tough and flexible, combining the strength of steel with the lower cost and ease of casting of iron. It's a truly remarkable material used in countless applications that are critical to our modern world, from the automotive industry to wind turbines. The secret to its amazing properties lies deep within its microscopic structure. If you were to look at regular gray cast iron under a powerful microscope, you would see tiny, sharp flakes of carbon called graphite. These flakes act like little cracks, making the iron weak and brittle. But in ductile iron, something magical happens. The graphite doesn't form into flakes. Instead, it curls up into tiny round balls or spheres. These round shapes, called nodules, allow the iron to stretch and deform under stress, giving it its signature ductility. So, how do we convince the carbon to form these perfect little spheres instead of brittle flakes? The primary ingredient for this transformation is magnesium. When added to molten iron, magnesium acts as a powerful nodulizer, forcing the graphite to grow into a spherical shape. This process is the cornerstone of producing all ductile iron. However, just adding magnesium isn't always enough to get the job done perfectly, especially when we are dealing with parts that have thin walls or complex shapes. Sometimes, you need a little extra help, an assistant that makes the whole process work even better. That's where our special element comes in. This is where the story gets really interesting. While magnesium is the star of the show, it has a very important sidekick, lanthanum. Lanthanum is what we call a rare earth element, and it plays a critical supporting role that is absolutely essential for creating the highest quality ductile iron. It works alongside magnesium, refining and perfecting the process to ensure the final material has the best possible strength and flexibility. For parts with thin and medium-sized sections, lanthanum isn't just helpful. It's often the secret ingredient that makes achieving perfection possible. Full potential of this incredible material. To understand why lanthanum is so important, we need to think about how those graphite nodules form in the first place. They don't just appear out of nowhere. Each tiny sphere needs a starting point, a microscopic seed to grow on, which we call a nucleus. The more of these starting points you have scattered throughout the molten iron, the more individual nodules you can form. This is precisely where lanthanum works its magic. It is an incredibly effective inoculant, which is a fancy way of saying it creates a massive number of these nucleation sites, giving the graphite countless places to begin its spherical growth. This increase in the number of nodules is a very big deal. When you have a higher nodule count, it means the graphite spheres are smaller and more evenly distributed throughout the iron. A higher count of smaller nodules results in a much finer and more uniform internal structure. This refined structure is the foundation of superior mechanical properties, making the iron both stronger and more ductile, allowing it to withstand greater forces before it bends or breaks. This is especially critical when casting parts with thin sections, like certain automotive components or intricate pipe fittings. Thin sections cool down very quickly. This rapid cooling doesn't give the magnesium a lot of time to do its job properly, and it can struggle to form enough nucleation sites on its own. It's a race against the clock, trying to get the structure right before the metal solidifies. The result can be fewer, larger nodules, or even the formation of undesirable structures that make the iron brittle. Lanthanum solves this problem beautifully by working in synergy with magnesium. By providing that huge boost in nucleation sites, it ensures that even during the rapid cooling of a thin section, a high density of graphite nodules can form quickly and efficiently. Lanthanum acts as a powerful insurance policy against the negative effects of fast cooling, ensuring consistency and quality every single time. One of the biggest enemies of a perfect iron casting is a sneaky defect called microporosity. These are tiny microscopic voids or holes that can form within the metal as it cools and solidifies. You might not be able to see them with the naked eye, but they can be devastating to the part's integrity. These little empty spaces act as stress points, creating weak spots where cracks can start and grow, especially when the part is under pressure or vibration. For a critical component like a brake caliper or a suspension part, microporosity is simply not an option. It can lead to catastrophic failure. These tiny voids often form during the final stages of solidification. As the iron turns from a liquid to a solid, it shrinks. If there isn't enough liquid metal available to fill in the gaps left by the shrinkage, these little pockets get trapped inside the casting. This problem is made worse by uneven cooling or issues with how the graphite nodules are growing. If the nodules grow too large or too slowly, they can interfere with the flow of the remaining liquid metal, blocking off the tiny channels needed to feed the shrinking areas and leading directly to the formation of these dangerous microscopic holes. This is another area where lanthanum proves its immense value. By promoting a high nodule count, lanthanum ensures that the graphite spheres are small and grow uniformly. This controlled growth helps maintain clear pathways for the liquid metal to flow until the very last moment of solidification. This allows the casting to be properly fed, effectively filling in any potential shrinkage voids before they can form. It helps the iron solidify in a much more organized and predictable manner. Furthermore, lanthanum plays an important role as a cleanup crew within the molten iron. Iron often contains small amounts of impurities like sulfur and oxygen. These elements are trouble because they interfere with the nodulization process and can make the iron less fluid. Lanthanum has a strong affinity for these impurities and readily combines with them, forming stable compounds that are effectively neutralized and removed from the equation. By cleaning up the melt, lanthanum ensures that the magnesium can work more efficiently and that the graphite can grow into its perfect spherical shape without interference, further reducing the risk of defects. When we bring all these pieces of the puzzle together, a clear picture emerges. Lanthanum is far more than just a minor additive. It is a powerful tool that enables the production of superior ductile iron. Its primary contribution is its incredible ability to increase the number of graphite nodules by creating a vast number of nucleation sites. This is the foundational benefit from which all its other advantages spring. A higher nodule count directly translates into a finer, more uniform microstructure, which is the very definition of a high-performance material that we can rely on for demanding jobs. This effect is most pronounced and most critical when we are working with thin and medium section castings. These parts are notoriously difficult to produce with consistent quality because they cool down so quickly. This rapid solidification can easily lead to undesirable structures and defects. Lanthanum directly counteracts this challenge, ensuring that a dense and healthy population of nodules forms even under these demanding conditions. It is the key to overcoming one of the biggest hurdles in modern foundry technology, allowing engineers to design stronger, lighter, and more complex parts than ever before. Beyond just creating more nodules, lanthanum is instrumental in preventing the formation of critical defects like microporosity. By controlling the growth of graphite and the solidification of the iron, it ensures that the casting is solid through and through, without the microscopic voids that can compromise its strength and durability. Its ability to scavenge and neutralize harmful impurities like sulfur and oxygen further purifies the melt, creating the ideal environment for perfect nodule formation. In conclusion, while magnesium may get the credit for starting the ductile iron revolution, lanthanum is the unsung hero that perfects it. It is an indispensable ingredient, a critical supporting element that elevates good ductile iron to great ductile iron. Incorporating lanthanum into their process is not just an option, it is the secret to success. Guys, if you enjoyed this video, hit that like button and subscribe for more content just like this. Don't forget to ring the notification bell so you never miss an upload.